tools, frameworks, and solutions we have in network automation or general automation. So we will later then talk about 3 tools, also to be able to compare them. But in the beginning, I would like to have an open conversation about maybe tools you already know, you have heard about. So who has heard about any network automation tools? Ansible? Yes, I've heard about that too. Or what kind of frameworks or what kind of possibilities we have? Yes? Yes, vendor-specific solutions, definitely yes. Anything else? Bash? Yes. SaltStack, we will talk about SaltStack today as well. Yeah, definitely, also an option. Anything else? There are, how can I say, there's way too many options. So, of course, we first have the option, should we take one product or do we take multiple products and combine them? So let's call this, should we take the huge software company approach where we buy a software like SAP and we need a lot of engineers to customize it until it works for us? Or should we more have the Linux approach where we have different small tools and then we pipe them together to a solution? That would be one discussion we would have to need. And the other one would be, should we build something by our own? Like, should we make some scripts? Could be Bash. I've seen Bash. Of course, we will do some Python here. Could be Golang. Could be Java. Could be C#. Could be whatever you want. So we have the possibility to say we want to have our homegrown solution. We want to build something by ourselves. And yeah, a lot of options. And if we go one of these paths, then we have more options. We have multiple libraries who does maybe something similar. So also here a lot of possibilities. The other thing is, we have heard Ansible, we have heard SaltStack. There are, from this, I would say Ansible and SaltStack, they both coming from the Linux configuration management area. So there we would of course also have Puppet, Chef, CE is another one. So many tools we could use for our purpose. And then when we talk about infrastructure as code, of course we would have Terraform or the new fork, Open Terraform or how it is called. Then we would have Pulumi. It's an approach where we can program our infrastructure. Then we have a lot of vendor solutions. Each vendor has their own solutions. Some are only for the vendor, some are inter-vendor capability. So yeah, we have way too many options in my opinion. The question is, what should we, or how do we decide which one we want? Which path do we go? So one of the questions normally is, do we have a green field or brown field? Does these terms make sense? Green field, brown field? Which one you prefer? Green field? And then you want to operate or you want to leave and not my problem anymore? Also to operate, okay. If we build something, you always have to think about who can operate this in 1 to 5 years. If you build a solution, hopefully you are not alone, hopefully you have a team. But yeah, someone has to maintain this. If there is an issue, if there is an update, someone has to be able to dig into the solution. Or of course, if you buy everything in, then you have the vendor support, but then you pay for this. In the end, if you pay the engineer or the software company, that's another discussion for the management. So we have way too many options. One thing or one problem I see is that we have too many snowflakes. What does it mean, snowflakes? I've seen some question marks in the room. Each network engineer or company believes that their network is special. I have some special requirements for my network. My network is different than the other one because of something. And this makes it even more complicated to see which approach should I take. What we are not discussing in this module is the whole issue with standardization. So before we can automate, we would need to standardize our products, our configuration. If we have 50,000 routers, for example, in my company, depending on the company, you can see which engineer did which configuration, just on the style how he did it. And if you want to automate something like this, you have to have a standard. It brings you a lot of benefits, but also needs some mind changes. Well, we today, in these 45 minutes, we only can cover some stuff. Sorry. So, better. We have then, of course, also the whole hype about cloud with even more tools. Then we have hybrid clouds, then we have abstraction of the infrastructure, all this stuff. Makes it more complicated. What I hope that you will take out of this lesson is that you have to really think about how you want to proceed, which path you go with your team. So if, for example, you're working in a company and the Linux team is using, let's say, Ansible, it's probably hard to say why you want to go with Puppet for your network. You can go with Ansible because you say we want to share knowledge, but who wants to talk to another team in the company? So, yeah, that would be definitely an approach. Question is it the best approach? If you have other requirements, because you are not automating Linux boxes, you're automating switches. Depending what kind of switches you have, they are Linux boxes, but yeah, maybe you have completely different requirements, so maybe you want to go with native Python. Or you want to go with Golang because you have Kubernetes and you want to build your custom resource definitions and want to use the ecosystem from Kubernetes with GitOps, for example, to automate. But in the end, what I think is the most important question, who can really support and maintain this stack? If I leave the company, will this application, this solution, still be perfectly fine in 5 years? Or will they have to rebuild everything because the new engineer has a new tech stack he likes? So, yeah. I still have one actually project I started 2015. It still haunts me until today because one company still heavily uses it and I'm the only one who kind of knows the whole stack. So that was one of my mistakes, my early network automation journey. But maybe I also did not document it perfectly. Yeah. So, but if you don't touch something for 5 years, it gets more and more complicated to operate, especially if you use a lot of open source tools who got involved or bought by companies, for example, and had some changes. I believe if you build something, you have to have a plan how we can maintain this, or the company can maintain this. I was always saying all this stuff is open source. All the parts, there are engineers who can support this, who can maintain this. It's no vendor locking. But to be fair, the whole stack itself got so complicated with so many parts. I think the application runs at the moment with around 20 Docker containers, that anyone could troubleshoot this. But until he understands what is really going on, he probably needs 1 week. And yeah, there's some stuff we have to consider. And of course we have to learn. So, possible approaches, way too many. Today, or in this module, we will focusing on Python. I know there is a lot of trend going. Let's use Golang, especially if you have some Kubernetes background, you want to use custom resource definitions. If you want to use gRPC, for example, for protocols, then there is a high chance that you will be happy with Golang. If you want to use a lot of tutorials and resources, you are already a good Python developer, you will be much faster in Python. So there is a lot of stuff we have to consider if we choose one. So brownfield, most of the time, each greenfield you start will be at one point a brownfield. So, yeah, we in the end always have to deal with brownfields. And the other thing we have to consider is who uses this solution, right? If we build something, if we build it for our team, that's one thing, of course, we want to make our job easier. But if we, for example, are responsible for a huge, let's say, merchandise company, different jobs, the management, they don't care if we have 1 or 100 VLANs at one location. They want to have the service. They want to comply to all the security policies, of course, but they don't really care about what is a VLAN. So if we then build a solution where they can say how many VLANs I need, it will be probably not the right solution for them. If we support or troubleshoot something, of course, we are probably caring about the details. But if you build something, who uses it, what is the purpose? And how many abstraction layers do I have to build? In the end, we want to have happy customers, so the customer definitely does not care how many VLANs I have in the shop. He just wants that everything works perfectly. We probably need technologies to provide the stable infrastructure, but yeah, keep in mind who wants to use this. If you build a solution, let's call it GitOps, perfectly nice pipelines, everything, and someone in the management department should make pull requests, maybe also not the right approach. Yeah, some terms you will hear sometimes. Maybe you have heard them already. If you have cloud ops or cloud infrastructure, you have seen some of these terms. If you want to win, let's call it marketing buzzword game, these terms definitely have to be there as well. Declarative, everyone knows what declarative means? Okay. Idempotent. Everyone clear? Idempotent means that I can do this function or this task again and again, I have the same result. So when we then talk about task, if I say I want to install an Apache, I can say I want to install an Apache. If the Apache is already installed, the task will not change anything. But if someone goes and deinstalls Apache, and I say I want to install Apache, it will be there again. So if we then talk about Ansible, for example, we will have a domain-specific language, our YAML, defining in a declarative way how we want to have the infrastructure, and the task should be, if we do it right, idempotent so that we can run these tasks every night, for example. And always make sure that the infrastructure is in this declarative definition. Yeah. Yeah. If you want to know more about tools, buy me a coffee. We can discuss about all the tools and technologies, why I think this one is better than the other one. And for each of my opinion, you will definitely find someone with another opinion. So, Ansible, we will also then see Ansible later. Ansible was really hyped by some companies. I think Ansible was bought by Red Hat in history. 2015 maybe? 16? So, long time ago for kind of open source tools. It's still open source. It has some changes. It definitely is not exactly in the way that the main developer in the beginning had the intent. So I had some talks last November when I was in the US, and the main idea of Ansible was at the time to have a documentation of your infrastructure, like kind of a markdown or something, and then you have code snippets where the tasks are executed. So you could run then the documentation and it's deployed to your servers. Nowadays, Ansible has many changes. It has many features, but yeah, it is in the end a Python tool where you can define your tasks, your workflow you want to do on machines, multiple machines, one machine, and then you can execute this to your inventory. So in the end, we will next week we have a guest lecture, but the week after we will then go a little deeper into Ansible. You also will have to do some self-reading, see the documentation. But in the way, we have now with Ansible a huge ecosystem. So we have, for example, also, let's see if it works. We have now this layer here who was added with a server. So we have different solutions. The most common at the moment, it was a Tower product. Now I think it's called Ansible Automation Platform, where we have a centralized server with let's call it beautiful UI, where we can trigger our playbooks and have our secret vault. We have inventory, we have APIs, we have cron jobs, all the stuff. Because Ansible itself, we talk about Ansible, it is more or less a Python tool who can run on your machine, on a server, but also anywhere. And the main goal was to have connection to a box, do a task, and then leave again. Let's call it fire and forget approach. Of course, it depends how we make our workflows, how we design the tasks. We have many task implementations, but the main, I would say, issue is we have a domain-specific language. So we have a YAML structure. We can have multiple ways how we struct this. We have options to make roles. We can import other tasks, other playbooks. But in the end, we have a specific set for task we can do. We can call a module, and we can give some parameters, and we can execute this on one machine, multiple machines. We can have some statements with conditions. But it's, yeah, everything had to be somewhere implemented so that we can now use this language, right? If we then later will talk about nonlinear, we will compare nonlinear and Ansible a lot. Nonlinear is basically just a framework for Python. So we have the whole Python language. And we have much more possibilities. One problem here is we have YAML. We have seen last time how YAML works, how we have some restrictions, how we have some stuff we have to be aware of. And what we also have is changer, who sometimes is used to do some logic because we cannot do it in the domain-specific language. And if you have already played a little with templates, with changer, testing templates is difficult. Sometimes if you do some stuff who are not really, let's say, 1 or 2 levels of loops, you afterwards need to take a shower, because it's just, yeah. In the end it will work. Question is it maintainable in 2-3 years? But it was never the goal of Ansible, to be honest. It is used now in many times in this way, but yeah. The architecture of Ansible is quite simple. We have modules where behind normally Python code is. So my recommendation, if you do Ansible and you have some more complicated stuff, write it in Python, create a module out of it, and call it from YAML. And don't try to do some stuff in changer, in templates. Yeah, that's just, in my opinion, not a nice way to do it. We have utilities, we have plugins, inventory, and playbooks are probably the 2 most important ones. We have an inventory where we defined which hosts are in our environment. We can have multiple inventories. If we start Ansible, we can say, I want to have the test inventory, or I want to have the production inventory. And then I can say, on all devices in the group, let's call access switch, I want to deploy a new SSH key. Or on all my web servers, I want to install the newest Apache version. So what we also will see in many examples, that Ansible really comes from the Linux ecosystem, and most of the examples and also the code itself is done for Linux. So Ansible, for example, in the default behavior, we will see this in the lecture in more details, he sends Python code to the box and then it gets executed. Most of our network devices, they don't really support this, so we will then move this to a temp folder on our box, and then the SSH or whatever API we use will then be triggered from our machine. But what I want to say is, Ansible was not designed for network automation. But of course we can make every tool, or almost every tool, somehow that it works for our use cases. This is a really simple example how this could look. We see here the combination of YAML with Jinja. In Ansible, this Jinja is executed task by task. Why do I say it so explicit? Because afterwards, when we talk about SaltStack, it is the opposite. So when we run this task, we will see then the inventory host name. So for all routers here, this can be a group, even if it's called hosts. For all routers, it will send the configuration line host name, and for router 1, it will be router 1. So this is then parallel, or depending on your CPU and all the stuff. Of course, it's not 100% parallelized, but it is threaded, or it is more or less at the same time, depending also we can define how many tasks can we run at the same time, with how many forks can we do. Yeah. And then the next task would be to send the configuration for the DNS server. Does it make sense to make 2 tasks if we can make 1 task and just send multiple lines? That's another thing. I want to say we have here a playbook with a play with 2 tasks. It's a list, it's YAML, it's stuff we know, but yeah, we will have some fun with Ansible, and also in the exercise. Any questions? Ansible was fast, was not deep at all. I cannot hide that I'm not the biggest Ansible fan. Even at my day job at the moment, I do some Ansible, but everything I can is in Python modules, and then we call it from Ansible. So Ansible itself, if we don't look about the whole ecosystem, is a configuration management tool. He's really focusing on executing tasks. So why do I say that? Because what we will see is now StackStorm, in my opinion, is a little bit more complex, has more capabilities. It's more going up to a level of orchestration. And the last tool we will see is StackStorm, who is then a real orchestrator, workflow engine, and not really focusing on simple tasks. So if you use a tool, you can also then have a combination and say, I want to have a workflow engine, StackStorm, and I want to trigger my Ansible playbooks. So I have the benefit of a real workflow engine where workflows can live for days, if it has to be, and I have my task execution framework, let's call it Ansible, where we can really have simple tasks that we don't really need a lot of magic and logic, because we can use a tool for the right job. But I can do everything with Ansible, I can do everything with SaltStack, or I can just keep both away and say I want to go with Terraform. As I said, we have all the options, but makes our life not completely easy. So SaltStack, I was a huge fan of SaltStack when I discovered SaltStack, because it was, in my opinion, more what I wanted to have. But sadly, it did not really lift up. When we compare, Ansible was the learning curve so much faster in the beginning that everyone was trying to learn Ansible because it was easy to get something in the beginning done. Afterwards, probably it gets harder if it gets more complicated, but then you already have Ansible. So that is one of the reasons why Ansible is so common. Even if you go to Ansible, I think the first word you see if you Google Ansible is simple IT or something. So they really also promote that Ansible is simple. And if you want to configure a DNS server on a Linux box, yes, it is. SaltStack itself is also a configuration management system where we defined in a declarative way how our system should look like. So the thing here is we have now minions and a master who is a server. We can even have hierarchy. We can have complicated stuff. I think one of the biggest company I know was LinkedIn. Not sure if they still use it, but the whole server, not sure how many they managed at one point with SaltStack. So it scales pretty well, but we have now not a simple Python script. Ansible is definitely not a simple Python script, but in the end it is a Python tool where we can run anywhere. Here we have server and minions. We have event bus between. So it gets more complicated. It needs stuff to be installed on the devices we want to manage. It also has the possibility to have proxies for devices we cannot install Python. We can have a proxy who is as close as possible to the device and then makes the raw connection. Yeah, it has a lot of stuff, but the approach is not completely the same. So normally in Salt, then I can also make some requests and say which router has this ARP entry, and then it goes to all of them, tells them, hey, do you have this one? Gets an answer back. So it's more an event-driven approach with an event bus, and yeah. We have to know the basics. I really would recommend also to check I think it's a 30-second intro on the web page. This is the Salt architecture. You already see it's more complicated. It also comes from the Linux area. SaltStack was open source until, or it's still open source, but VMware bought SaltStack in 2022. must be around autumn 2022. You don't have to know all the dates for the exam, don't worry. I also sometimes I like to have this in mind just to know how the ecosystem is evolving, who is buying who. But yeah, it's just to see that these are not just some small project someone did once, published it, and got never any updates. So here we have minions. On these minions we have beacon grains where we then feed back, and we can, for example, say I want to execute this task on all the devices who have a Red Hat version 8 or who are Windows and 2000. What we have 2022, I assume. Not in the Windows Server area anymore, but yeah, we can then also have some decisions about informations we feed back to the master. We can also have multiple masters. We have a runner where we can run tasks, we can interact on events. We have Reactor, who we can say if a device, for example, sends an event that more than 80% of the disk space is occupied, I want to execute the task. So we have here already some event-based. Of course, probably I have a monitoring system who will also alert me, and then I can, for example, trigger my stack, my workflow engine. So this here would say is between a workflow engine and a simple task execution. It's more complex. It also uses YAML and Jinja. The nice thing here is if you don't want to write YAML, you could also write a Python file who in the end just needs to return the same data structure. And as I mentioned, if you use Jinja in the YAML, it gets rendered before the tasks are then executed. So you can create new tasks with Jinja. While in Ansible you can of course use the DSL commands with loop, for example, to execute something multiple times. But it's the opposite approach. So if you have to work with both, that's something you have to keep in mind. Yeah. In Salt, we have two approaches. One would be to define the top state and say on all machines they have web in the name, I want to make sure that the Apache is installed. On all Linux VMs where I have DB in the name, I want to make sure that Postgres is installed. On all routers with this and this name, I want to make sure that these VRFs are deployed, or these BGP sessions are up, and full mesh and all the stuff. That is one approach. Then you have this top SLS file where you can say I want to have my state deployed. You can also check if it's not the case. Or then you have simple task executions where you can say I want to look for this MAC address. Yeah. But to run this, you need kind of infrastructure. If you manage in Linux, if you install a minion or an agent on this box, it's not so much more overhead. But if you have 10,000 routers, they cannot run the minion itself, and I have to run 10,000 Docker containers just to manage them. That can be a little disappointing. There are now also approaches, open source contributions, where one proxy can manage multiple devices. And what I also have seen is plugin where I from Salt then can trigger non-near and execute non-near stuff, so I can make some combinations. If your company has Salt, that's definitely nice. There is a company here in Rapperswil, I think walking 10 minutes, is one of the bigger web hosting companies. They use Salt. So it's also used somewhere. Switzerland, there was there is probably still a Swiss bank for the infrastructure using Salt. Or at this time, they were using Salt. It's always, many companies don't really share the tech stack for the automation, especially Swiss banks. They don't, many of them don't share what they actually are doing. Some are making some really nice stuff, but because it's closed behind bars, it's difficult to say. Who works for a Swiss bank? Okay, no offense. You are sharing your infrastructure automation journey with the public? No. Yeah, I assumed. But because I know which kind of vendor you use, I maybe already know which bank it is. So, StackStorm. Maybe that sounds familiar for some. StackStorm is this workflow engine. So the goal here, it was open source, then it was bought by a vendor. The vendor did some enterprise features, then this vendor was bought by another vendor. They kind of pushed this back to open source, even with the enterprise features. So for example, the workflow creator or composer, I'm not sure how the component at the moment is called, was also released. So now this is back in open source space. It's part of the Linux Foundation. So it's also not just a small tool, but there are many products, many open source workflow engines. So I don't want to say this is the one you have to use, but this is one of the options, and it's more about in which level they operate. So StackStorm, it's, if you install it, even more complicated, because it is a workflow engine. It has to be stable. Normally you want to have a redundancy, because yeah, if you install this, the best way at the moment would be a helm chart. You install it on your Kubernetes cluster, everything comes up, but you have multiple databases. You have somewhere must be a Postgres database, but we also have MongoDB, we have Redis somewhere, we have workers, we have rule engines. So it is kind of a complex system itself. To looking at the source code at the last hackathon or Hacktober, well, probably 1 year ago, I always try in October to make one open source contribution to a project I like, but I'm not really using it so much. So here, probably 2 years ago, I made a pull request for StackStorm. It's a nice community. You have Slack and everything. You can talk with them. It's big, in my opinion. Many uses it, and yeah, it has in the end also web UI. Even this workflow composer, where you can compose your workflow with drag and drop and all the stuff. I have never used this one in production. I normally would write, surprisingly, YAML files again to define my workflows, also to find my actions. An action is normally a YAML file describing the action and then an execution. That can be a Python, that can be a shell, that can also be a remote execution to somewhere. So we have this kind of system where we have actions. Actions can combine to workflows. Here we can have workflows where we start together, then we have some parallel workflows, then we come together. We have a powerful workflow language, but it is again a domain-specific language. So we have some limitations there as well, but the workflow can trigger a workflow again. If you want to look at a workflow engine, this is definitely one of the things we have. Then we have sensors. So the simplest sensor probably is a button in the UI or a CLI command, but most of the times we would use webhooks, where, for example, if we have a single source of truth, we can say if someone deletes this, let's say this service, then we trigger an event, and with the workflow we deprovision. Or the opposite, if someone creates something, we provision this with a workflow. One thing you have to keep in mind, if you have to create multiple stuff in a UI, in your single source of truth, we will also talk about this later in the module, at which step can I really then make the automation. If I say, as soon as someone defines, let's say, a new VLAN on this access switch, if we really want to work on this level, normally if we have workflows and abstraction, I don't really care about VLANs and numbers and all the stuff for IPs, or I want to have services. But if I define something and I immediately trigger my workflow, but this person says, oh, I made a typo, all these cases can then get fast complicated. So we have to think about also how we want to use this stuff. And one approach I hope in the future will be easier is this kind of Git flow approach for our infrastructure, where we can say, I want to make a pull request, and if I have everything ready and it is reviewed, I want to apply it. But if we work event-based with the webhooks, this is at the moment a little tricky with most of the solutions I know. But we are getting there. Otherwise, if we don't get there, we will make some bachelor and thesis until we get there. Yeah, we have rules where we can say which trigger from a sensor will execute which workflows, all the stuff. Of course, we have a trigger who can be time-based. Yeah. So in the end, it is what you think about if you think about the workflow engine. It's one of the many ones who are out there. Sometimes you have to think about, should I use this one? Or do I just make a simple Python script? Do some cron jobs? It really depends on your use case. If you only want to have, let's call, network backups, it's probably not the idea to spin up a huge cluster with a workflow engine to log into each device on Sunday morning to make configuration backup. That's easily with, let's say, 15 lines of Python code and a cron job, if you know the right libraries. And of course there are some libraries and tools that do it already. So yeah, if this is your use case, probably not a workflow engine. You can also do it with Ansible, definitely. Probably, let's say, 10 lines of YAML in Ansible, and the inventory will give you this as well. And the cron job executes it somewhere, you're fine. Of course, you have to then make sure that the backup is working. If 1 year later you have an issue and you think, I have a backup, and you don't have one, that would be not so funny. On the other side, if you really automate your stuff, why do you need a backup? If you have a single source of truth, everything is somewhere declarative, you don't need backups, right? We can have a whole discussion if you still need backups, if you have hardware issues, you need to replace hardware. There are different approaches. But these are the kind of questions you have to also have in your team. So, we have 2 minutes left, if my clock is right. Any questions about the whole ecosystem? Everyone already disappointed that there is not one solution who fits them all. We don't have a ring who can, talk to all vendors. What kind of infrastructure you have, what kind of vendors you have, will also have an impact. If you have a nice vendor, he has some nice APIs and he has documentation. If you don't have so nice vendors, you have documentations who are not correct, you have APIs who are not working as you would expect. In network automation, you have to be aware that some companies, some vendors, they are really good in making your life interesting. Any questions? Okay, thank you very much.